So sometimes we'll be given points on the circle, sometimes we'll be given the center, sometimes we'll be given the radius. It's just various information. So let's start with what the standard form of the equation of the circle is. So the standard form for the equation of a circle is x minus h squared plus y minus k squared is equal to r squared. So lots of variables. Let's break down what they mean. HK is the center of your circle. Okay, HK is the center of the circle. R, what do you think R is? The radius. Okay, R is the radius. R is the radius. So whatever our equation is equal to, we're going to have to take the square root to find that actual radius. Okay. So let's just start basic. Okay, let's start basic here. Well, before we do that, let me just give you a little bit more information on a circle really quickly. Think about what a circle is. The circle has a center, and you know the radius. So all the points on the circle are the same distance from the center. That distance is the radius, okay? That kind of makes sense, but when I start talking about the points on the circle being the same distance, that starts to confuse people. But just think about it. You got the center, you got the radius, that creates all the points that are on the outside. So distance may come into play somewhere or another. And honestly, that's where the equation, the standard form of a circle comes from, is it has to do with the distance formula. Okay, it has to do
all carpentry students should be in class at this time. All carpentry students should be in class.
Good timing, guys. All right, so let's write some equations given some information. So this time we're given the center and the radius or the diameter. So to write this equation, it's always x minus the x coordinate, so x minus 5 squared plus y minus the y coordinate squared. Now, sometimes that will end up being a plus sign because one of those coordinates was a negative, so subtracting a negative is the same as adding a positive. But let's get back to this equation. Is equal to the radius squared, so the radius was 2, so 2 squared is 4. That's all we do. We leave it in that form. I can look at that equation and I can say the center is 5, 3, the radius is 2. Okay. Number 2, this is what I was talking about. X minus a negative 1, subtracting a negative is the same as adding a positive. So we would write that as x plus 1 squared plus y minus 7 squared is equal to 14 squared, which is 196. Yep, 196. Okay, number 3, that would be x plus 2, because it was a negative 2, plus y plus 11 squared. Don't leave those squares off. If you don't have the squares, then it's not a circle, it's a line. Bless you. Is equal to, do I square 18? No, because 18 is the diameter. We square the radius. So if the diameter is 18, the radius is 9. So 9 squared is 81. Now, number 4, the center is 0, 9. If one of your coordinates is 0, then you don't need the parentheses with that one, because x minus 0 is just x. So that's x squared plus y minus 9 squared is equal to, the diameter is 32, so my radius is 16, and 16 squared is 256. Okay, number 5, center is negative 4, 0, so that's x plus 4 squared, plus this time the y coordinate was 0, so it's just y squared, is equal to, my radius was a square root. If I square a square root, I'm just left with what's under the square root. One more like that. Center is 15, so x minus 15 plus y plus 6 squared is equal to, again, the radius is the square root, so when you square the radius, square the square root, you're just left with the 158. Okay, suppose that we are given the graph and we want to write the equation. Okay, we're going to have to look at this graph and we're going to have to figure out the pieces. We got to figure out what the center is. Now, luckily they have it marked. If they don't have it marked, just look at it as halfway horizontally and halfway vertically. Okay, that's where your center is. So let's see here. That's at 1, 2, 3. 3, negative 2 is the center. I'm going to identify it first instead of just trying to put it straight into the equation. If you can put it straight in the equation, go for it. But I'm just trying to prevent careless mistakes. So 3, negative 2 is our center. The radius, I just go from the center point and either count one way, straight out one way or another. Straight up, straight right, straight left, straight down. Go straight in one direction or in the other. So 1, 2, 3, 4, 5. The radius is 5. So my equation would be x minus 3 squared plus y plus 2 squared is equal to 25. All right, different information. We're given the center and a point on the circle. So to write the equation, we got to know the center. Well, they gave it to us. We need to know the radius. They didn't give us the radius, but they gave us a point on the circle. So back to that original idea. Every point on the circle is the same distance from the center. So we are going to use the distance formula with the center and the point on the circle. So if you don't remember the distance formula, let's write the distance formula over here in the big space, just in general terms. Distance is the square root of x1 minus x2 squared plus y1 minus y2 squared. That is our distance formula. So we subtract the x's, square them, add them to the difference between the y's squared. The good thing about the distance formula is you're squaring these values, so it technically doesn't matter what order you do it in. Now, I'm going to type in everything in my calculator but the square root. And the reason why I do that is in case this is not a perfect square. And in this case, it's not. Okay, so that distance is the square root of 40. That distance represents my radius. So I'm going to go ahead and say that equals r, so that I can very easily write the equation. Use the center. Make sure you don't use the point on the circle. HK is always the center, so x minus 9 squared plus y minus the 10 squared is equal to the radius squared, where the radius was the square root. That square root, it cancels. So I'm just left with the 4. Okay, let's do another one like that just to make sure we've got it. If you're given the center and the point on the circle, find the distance. Subtract the x's, square them, subtract the y's, square them. Make sure that you keep those negatives in there. Now, me personally, I don't want to have to type all that stuff in my calculator. If I'm subtracting a negative, that's the same as adding a positive. That way I don't have to worry about missing a sign in there. So 1 plus 7 squared plus negative 5 plus 13 squared. Now, if you don't feel confident about changing those subtracting negatives and making them positives, that's fine. Then just type it exactly into your calculator like you plugged it into the formula. I'm just trying to save myself a little bit of effort there. So x minus 1 squared plus y plus 5 squared, because I'm subtracting a negative 5, is equal to, my radius was the square root again, so I square the square root, so it's equal to 128. All right. 10 and 11 are just like that. I'll leave those for you to do here in a minute. Let's look at what if we're given the circumference or the area. Okay, it all goes back to what do we need to write the equation? We need the center and we need the radius. Okay, they gave us the center. They gave us something else. It must be enough information to figure out our radius. So let's remind ourselves of our circumference and our area formula. Circumference is 2 pi r. Area is pi r squared. So in number 12, they gave us the circumference. 6 pi, set it equal to the circumference formula, 2 pi r. Solve for r. Divide by 2 pi, the pi's cancel. 6 divided by 2 is 3, so our radius is 3. So when we write the equation, x plus 1 squared plus y minus 4 squared is equal to our radius squared, so it's equal to 9. In number 13, 17 pi, they gave us the circumference, so 17 pi is equal to 2 pi r. This time when we divide by 2 pi, yes, the pi's cancel, but 17 over 2 does not reduce, so we just leave it as a fraction. So x minus 9 squared plus y minus 12 squared is equal to, when you square a fraction, you square the numerator and you square the denominator. You could also just put it in your calculator, 17 over 2 in parentheses squared. I know it's going to be a fraction, so I might as well just tell it to turn it into a fraction. 289 over 4. That came from 17 squared is 289, 2 squared is 4. All right, what if they give me the area? Okay, if they give us the area, we set 16 pi equal to pi r squared. So if I divide by pi, that cancels. I've got 16 is equal to r squared. Do I really need to completely solve it for r? No, because my equation for the equation of circle is equal to r squared. So if that's r squared, there's no point in taking the square root because I'm going to turn right around and square it again. So I'm just going to stop. I don't have to find out that the radius is actually 4. This one's easy, but I can stop at that step because it is just the radius squared. It's just the radius squared. So I really don't have to do any work on this one, do I? For number 15, what should it be equal to? 361. Because that number with the pi is r squared, because it's area. Pi r squared is area. So if area is given to you in terms of pi, it's the number part is r squared. You really don't have to do any work. All right, let's look really quickly at number 16. I'm just going to do one of these because it's pretty easy. If you're given the equation, you got to be able to tell me what the center and the radius / the diameter are. So you got to pull it out. When you pull it out, you got to change the sign because we changed the sign when we put it in, right? So this would be +5, +1 would be the center, and that's equal to r squared. So the square root of 64 is 8. So the radius of that one is 8. Let me do one with the diameter just to make sure. Okay, number 17, center would be -7, +2. Change the sign when you pull it out of the equation. 324 is r squared, so if I take the square root of that, it's 18, but it wants the diameter, that's the radius, so I'm going to multiply it by 2. The diameter of that circle would be 36. Okay. So, y'all do 18 and 19 really quickly.